Hello everyone, welcome to Project 7 of the Electronics Engineering Kit series, using an NPN transistor to power an LED. In this project, we will be using a transistor to turn an LED off and on, and use it as a switch. To complete this project, you will need one Arduino Nano, one breadboard, 4 male-to-male jumper wires, two 220 ohm resistors, one transistor, which can be seen as this component with 3 prongs, and an LED. This project is intended to teach you about NPN transistors. There's also a component called PNP transistors, which have not been included in this kit, and they have a separate function. An NPN transistor is a 3-pin semiconductor with a collector on its left side, a base in the middle, and an emitter on the right. And it helps to switch current or amplify or increase current. It can be found in virtually every electronic device, such as your phone, a CPU, and even audio systems. Now, let's put together our circuit. I've already placed the Arduino on the breadboard, and so the next step would be placing our LED as well. I like to make sure that the ground of the LED is on the left-hand side. Next, let's connect the power of the LED to another row using the resistor. In the previous projects, I've used this resistor to connect the ground of the LED to the ground of the Arduino. But it doesn't really matter where you place the resistor as long as you keep it somewhere in your circuit. In this case, I'll be using it on the power of the LED. And you want to make sure that the other end is on a separate row. Now you want to add power to this LED by connecting the 5 volt of the Arduino to this resistor. Here we have 5 volts of electricity flowing through this yellow wire into the resistor and then into the LED. Now let's connect the ground of the LED to another row. And so what we want to do is take the other wire after one part of it has been connected to the ground of the LED and place it in a completely new row. I like to keep it on the other side of the breadboard, but it doesn't really matter. Now let's connect our NPN transistor to the circuit. Make sure that the flat end of the transistor faces towards you. Now, the left prong is the collector pin. This is where you want electricity flowing into it. The base pin, or the middle pin, is the pin that determines whether electric current is able to flow through it or not. If there's electricity added to this base pin, then current will be able to flow through the transistor and our circuit will be just fine. But if there's no power added to the base pin, then the circuit will essentially be stopped. Finally, the right pin is the emitter pin. This is where electricity is coming out of the transistor. When we place it in our circuit, we want the ground of the LED connected to the collector, or the left-hand pin. What I like to do is have the flat end facing away from me, and then place it in like so. Make sure to push it all the way in to make sure it's connected on the breadboard. Now let's connect the second 220 ohm resistor to our circuit. What we want to do is prevent too much current going through the transistor. And as a safety measure, we're going to place this on the base pin. Here we'll connect the base pin and have the other end of the resistor going and connecting to a completely new row. This is because we'll be adding power to the base pin, and we want to make sure that not too much current is flowing through it. Now we want to power our base pin and use this wire to connect the digital pin 2, which has been coded to output 5 volts of electricity and then pause in a repeated cycle. And we want to connect that to the resistor, which is connected to our base pin. What this will do is that it will add power to the transistor to allow current to flow through it and complete our entire circuit. But when power is stopped and there's no power going into the base of the transistor, then the circuit will be broken and electricity will not be able to flow through this transistor, which essentially stops our circuit and prevents the LED from turning on. Now let's complete our circuit by adding this wire, which connects to the emitter of the transistor and connects to the ground of the Arduino. Again, the emitter of the transistor is the right prong if the flat end is facing towards you. So if it's facing away from you, then it's the left prong. Now the circuit is complete. Now let's power our circuit. Here I'll be using this USB-C wire and power bank, but you can use your closest outlet. Here, as I power the circuit, the LED should flash on and off. This is because as the digital pin 2 adds 5 volts of electricity to the base pin of the transistor, the circuit is fully connected and all electricity is then going through the LED, through the transistor, then into the ground of the Arduino. But if there's no power added to the base of the transistor, then the circuit is essentially stopped because the transistor will not allow electric current to pass through it if there's no power added to the base pin. Congratulations, you've completed the final project of the Electronics Engineering Kit series.